Well, hi there. Happy Friday. I know it's a Friday, and so this lesson's going to be really quick, like less than 10 minutes. That's my goal. All right? Okay. Properties of definite integrals. What you can and can't do with a definite integral. All right, so let's start out. The first property. If you have an integral that goes from A to A, think about that geometrically. You're starting at point A, you're ending at point A, so how much area is between those 2 points if you start and end at the same spot? The answer to that is 0. So if the bounds of an integral are the same on the top and the bottom, then the answer to that integral is 0. All right, next property, additivity. If you have an integral that starts at A and then goes to B, and then the next integral starts at B and continues on then to C, you can take those two integrals, you're just basically adding the area together. And so you could summarize that and say, okay, well that's the same as just going from A to C, blowing right through B anyway, and so that you can add those two integrals together. Okay, the order of integration. So if you look at those, we've got now B is the bottom bound and A is the top. So if you would like to reorder the bounds of integration, you need, and then put A on the bottom and B on the top, then you need to multiply the integral by a negative number. So multiplying by a negative will switch the order of the bounds. The next one, a constant. What are you allowed to do with that? So if the number k here is a constant multiplied, you are allowed to pull that out to the front of the integral, and so k would sit out in front from A to B of the integral. You can do the same thing with a negative, because a negative is just the constant multiple of -1. And so you could pull the negative out from A to B of f of x dx, and then you could use the negative rule, and the negative rule would change the bounds from B to A if you wanted it to be positive. So that would, either of those would work. And then the sum and the difference rules, as you can add or subtract integrals separately. So if you have two integrals added, you are allowed to split them up and have f of x be its own integral, and then have g of x be its own integral. You can split up addition or subtraction. You can't do that to multiplication, you can't do it to division, but you are allowed to do it with addition and subtraction. So let's use those rules and see what we can do with some of these integrals. All right, so let's look at the first one. Find the integral from 4 to 1 if possible. Now I look at what I've been given, and I have been given -1 to 1. I've been given 1 to 4, and I've been given -1 to 1 of an h function. And I want to find 4 to 1. So I need to switch the bounds so that it is 1 to 4. And so I'll use the property that says you can switch the bounds if you put a negative in front. All right, and if the integral from 1 to 4, if the amount of area from 1 to 4 is a negative number, then the answer to this would be -2, the opposite of -2, and so the answer would be 2. All right, next one. Find -1 to 4 if possible. Well, I don't have -1. Now I want -1 to 4, all the area from -1 going to -4. Okay, well what we've got is we've got the area going from -1 to 1, and then we have more area going from 1 to 4. So we can put those two things together. We can say, well, this must be -1 to 4 must be equal to -1 to 1 of f of x dx, that area, added to 1 to 4, that area. And so that would be 5 plus negative 2. So 3 must be the total area altogether. Okay, last one on this section. Find negative 2 to 2 if possible. So what do we have? We have negative 1 to 1 of h of x. Okay, and we know that that is equal to 7. So that means the area between negative 1 and 1 is 7. What can I learn about the area from negative 2 to 2? Okay, well, the answer is nothing. Some people might be thinking, oh, I can just double the bounds. Like, can I just times this by 2 and times this by 2 and then times this by 2? No, the answer must be 14. No, that is not true, because you have no idea what's happening on the interval from negative 2 to negative 1. It could be below the x-axis, it could be a totally different shape. You have no idea what's going on the interval from 1 to 2. Again, could be a totally different shape altogether. So there's no solution that you can gain. It's not possible to find that interval. So here's more of an abstract one. If the integral from a to b of f of x dx is a plus 2b, then what do I have if I add 3? So you can think of this geometrically. You can also think of this algebraically. So algebraically, using the properties, this addition here can be split up into 2 separate integrals. So I can have a to b of f of x dx, and then I can also apply the integral a to b to the constant number 3. Make that look a little nicer. So I already know that this is a plus 2b. Okay, that integral has that value. But then what about the integral from a to b of the constant 3? So we can think of this geometrically, or we can think of this as an antiderivative. If I do it as an antiderivative, then I would have 3x plus the constant c going from a to b, which would be 3b plus the constant c minus 3a plus the constant c. So overall, we've got a plus 2b plus 3b, constants cancel each other out, minus 3a. So altogether, that's negative 2a plus 5b. So that's one way to think of it. You could also think of this geometrically. You could say, all right, some function, hang on. Okay. Some function, I don't know what it looks like, but some function from a to b already has the value of a plus 2b. If I add 3 to this, I would be moving this function up 3 units instead of where it was. And so then that's going to give me a higher amount, and I moved it up 3. So now I've got the original shape, which was a plus 2b, multiplied by, or in addition to this new rectangle. And that new rectangle is base times height, so 3 times a minus b. And so then I can distribute and add those up, and either way I'd still end up with the same answer. So there are different ways that you can use, excuse me, it's not a minus b, I wrote it backwards, b minus a, sorry. Just looking at that and realizing I wrote it wrong. Okay. So you can do it geometrically, or you can do it algebraically and come up with the abstract answer. All right, I got this under 10 minutes, 9 minutes and 50 seconds. So I hope you guys have a great weekend, and I'll see you next week on Wednesday.